In the previous video, you solved 4 systems of 3 equations and 3 unknowns. You found that the first one has a unique solution, the second one has infinitely many solutions, the third one has no solutions, and the fourth one has infinitely many solutions. Using the same terminology as before, the first one's complete, the second one's redundant, the third one's contradictory, and the fourth one is redundant. And the first one is non-singular, while the other 3 are all singular. Now, just like with systems of 2 equations and 2 unknowns, an easy way to find if a system is singular or non-singular is to turn the constants into zeros and to study that system. And now that you have simplified the system with zeros as the constants, then let's look at the solutions. The first system, we know that it has a unique solution since it is non-singular. And furthermore, 0, 0, 0 is a solution because setting a, b, and c equal to 0 is a solution to the system. Therefore, the unique solution is the point 0, 0, 0, and the system is complete and non-singular. Now, notice that systems 2 and 3 are now the same system because we set this constants to be 0. What are the solutions to the system? Well, take a look at equations 1 and 2. The only difference between equations 1 and 2 is that equation 2 has an extra c, and c must be equal to 0 because that c doesn't change the result, which is 0. Therefore, c is equal to 0. And if you plug that into the first equation, you get that a plus b must equal to 0. So a is equal to minus b. So all the points satisfy that the first coordinate is equal to negative the second coordinate, and the third one has to be 0. And this system is redundant and singular. And the fourth system, well, its solutions are all the points for which the 3 coordinates add to 0. That means a can be anything, b can be anything, and c needs to be minus a minus b for the 3 to add to 0. And the system is redundant and singular. And just like before, each of the systems is associated with a matrix that keeps track of its coefficients. Again, in each row you have each equation, and in each column you have the coefficients of each of the variables a, b, and c. So the matrices are these ones. And using the same notation as before, these matrices are singular or non-singular based on if the systems are singular or non-singular.